Okay, good morning everyone. Welcome to the first lesson for volume. Okay, we're going to should have done your starter, which is the cold task for either year 5 or for year 6. I'd just like to explain that this cold task you aren't expected to get all of these correct, if anything at all, because this is the start of our unit and it's just to gauge how much you know about the topic. And then you'll do it again at the end of the topic after we've done all our lessons and teaching and learning, and then hopefully you'll show that your understanding about this topic has grown. Okay, so please don't worry about getting anything wrong in the cold task. Okay, so we're going to start our lesson now. Okay, so what is volume? I've got an image here, a rather large melon and a rather smaller apple. What can we say about these two fruits? What is volume? What do you think it is?
That they're like, is it like the lines that go round?
Okay, you think it's the lines that go round? Okay, good try, yeah.
I think it's the area of a 3D shape.
Okay, an area of a 3D shape. Interesting, thank you. Okay, well let's just think about these things. So it is actually the amount of space or solid space that something takes up. Okay, so thinking about our image of our melon and our apple, what can we say? Which has the most, out of those two items, the most volume? How much solid space does it take up? Yes?
The melon.
Right, so you can see the melon has a greater volume than the apple. You say it. The melon has a greater volume than the apple. Likewise, we could compare the apple and say the apple has less volume than the melon. Excellent. Okay, so there we are using already the language to compare, which is part of our learning objective, to understand what volume is and to compare volume. Okay, it's very different to what we call capacity. I'm using that word now gingerly because that's not what we're really focusing on today. So we're thinking about that containing. So if I've got my cup of coffee, it would contain a certain amount of liquid. Okay, that's different because that's how much a cup can hold. Okay, which is different to what a solid would contain. Okay, right, I've got a different type of cantaloupe melon here. So what can we say about these two images? Looking at this image compared to this image, what's the same about this? What's different about this? Yes?
One's cut up and one's in a circle.
One's a solid, yeah. So one's a solid and one's cut up, yeah?
They've both got the same sort of like space in them because you've just cut them up, so if you put them back together it will make a solid again.
You're onto something there, well done, absolutely. So this, even though it's one whole, that's got a certain amount of volume, hasn't it? Whereas this one, it's all cut up. Has it got the same?
Yes.
Yes, so it doesn't matter what it looks like, it's still the same money, but it's just been sliced up into pieces, into fractions, but it's got the same volume. Good teaching point and learning point there. Okay, so here we've got 3 little cubes. Okay, this set here, can you see? They are separate. And this one here, they're in a certain arrangement. What do we notice? What's the same? What's different? Yes?
One's apart, one's solid.
Yeah, one's all apart and then one makes up one solid. What can we say about those? What can we say? What can we generalise about them regarding their volume? Yeah.
They've got the same amount of little cubes.
Yeah, so these 3 cubes have got the same volume as the other 3 cubes. Absolutely. Nothing, it's just the arrangement that looks different. Okay, well done. Okay, you've got some cubes in front of you. For you at home, I don't know if you could find some something to visualise. Okay, so have a look at a go at how many different ways can you make these 4 cubes look different. Okay, so pause the video now and have a quick play. Okay, well done, welcome back. Okay, so you should see that we've got 3 different ways of methods here. You could have used, I can see one person here's got a vertical arrangement there. One person's got like a T over there. Well done. One person's got an arrangement like the building blocks there. Well done. So what can we say? What's the same? What's the same with these?
They've got the
Blocks.
same number of cubes in each one.
Yeah.
4.
Well done, so it doesn't matter how they look, they still contain the same. The volume is the same. Okay, well done. Okay, that's looking now, I can leave the cubes. Okay, so here we've got a little larger arrangement of this cuboid. So we've got, you can see the cubes being drawn and so you can see them clearly, but we've also got dimensions. This is where we're going to be thinking about formulas. Okay, now how can we find out the volume of this cuboid? Yeah?
You would do the 3 times 2 in the base, and times that by the 2, which is the height. And if you times the 3 by 2, that would get you 6, and then you would multiply that by the 3, which would give you 18 centimetres.
You can, well done. Now, you've done it slightly different. You've done the length against the height and then the width, didn't you? Well done. So it does get you to the same result, but looking at our example here, we've got the dimensions of 3 by 3. Can you see we've got this? The length, the 3 by 3, then we've got it multiplied by the width. So it's length times the width, which gives us almost what we would find out here. Do you remember? So it's almost like finding out the area of the base, like how we found out the area of a rectangle. I want you to bear that in mind. So we're going to be doing our length times our width, but then our further, we're going to be timesing it by the height. Okay, and there's our example. So we've got our 3 centimetres times by 3 centimetres, which gives us 9. And then we've got our 9, then we're going to multiply the 9 by 2, which gives us 18. Notice we are not writing centimetres squared.
What is cube?
Look closely. What is it? Yes.
It's the answer for the 3 by 2 by 3 would be 18 centimetres cubed.
Well done, it's cubed. So I'm going to just write that on our board to remind us. For example, e.g. 18 centimetres, and then it's like a little 3. Okay, that gives it the idea it's definitely a 3-dimensional. Okay, and underneath, I'm sure we can move that on the screen. Yeah, we've got our length times height times width. Okay, all good. All right, so we've got a couple of examples here. So have a look at one of these. Let's look at this one here. So we can see that we would do this. So we would do 3 by 1 by 2. Can you see that? And this one here we would be 3 by 2 by 2. This one here would be 3 by 3 by 2. This one here would be 3 by 3 by 3. Okay, so using the formula that we've used. Right, so on your follow-up, your challenges, you have got a chili 1, a chili 2 and a chili 3 to choose from. The chili 1 has got we can see each brick almost like it's transparent. Chili 2 has got like representation, so you can almost see through those cuboids. But chili 3 has got another step involved because you've got to visualise these shapes of these blocks, but then think about how they would be if they were a full cuboid. Okay, as in imagining that. Okay, so look forward to having a go at your challenges this morning and look forward to seeing them on Seesaw.